What's up everyone? Welcome to this video. Now today we're going to build a very simple web service or a REST API using FastAPI and SQLModel. This is going to be an update video to a video that I made 2 years ago. I hope you enjoy and learn from this video. Without further ado, let's get right into it. So what we're going to first of all do is to open up our text editor with a blank folder. So I'm just simply going to open up a new terminal window. And within that terminal window, I'm going to create a simple directory. Let me just call it FastAPI SQLModel, and let's say Postgres. So inside there, I'm just going to enter the folder, and once I enter the folder, then I've called it SQLAlchemy model. So I'll just enter this folder and make this a little bit bigger so that you guys can see. So the first step was creating the folder and entering the folder. Now I'm in the current folder, which is that folder I've created. Let me go ahead and try to open up VS Code within that folder. So when I do that, a VS Code will open up in that specific folder. What I'm going to do at first is to create a simple virtual environment just to isolate the dependencies of that project within the virtual environment, or to isolate them. So what I'm going to do is to open up a terminal window right here, and inside this terminal window I'm just going to use Python's inbuilt virtual env module. So the way I'm going to do that is with Python 3-m venv, and I'm going to call my virtual environment env. So by creating this as env, all we have to do is to first of all activate it with source env bin and activate, and that will make us enter our virtual environment. So my terminal is going to display version 3.10.12, but you may have something like env before the beginning of your user. So in this case, if I am to confirm, if I say Python 3, I'll notice that I'm now using Python 3.10.12. So our virtual environment has been created. So let's begin by first of all installing FastAPI and setting up our simple web server. So to do that, we're going to first of all begin by installing FastAPI. So I'll say pip install FastAPI, and this will go ahead and collect FastAPI, add it to our virtual environment. So once that is done, we're going to now go ahead and also create our simple web server. So I'm going to begin by setting up a directory structure. I'm going to first of all create a folder that I'm going to call the source folder. In this new folder, I'm going to add an init.py file to just help us make this folder a Python package. So to do that, what I'm going to do is to add a double underscore or a danda init.py file. And once I've been able to do that, then inside here is where I'm going to create the FastAPI instance. So this is like the main entry point to this source directory, and it's where we're going to put our FastAPI instance. So to do that, I'm going to say from FastAPI, I'm going to go ahead and import FastAPI, and once I've been able to do that, I'm going to go ahead and basically create a FastAPI instance. Now, after creating this FastAPI instance, we are going to be doing everything we want with this instance from here. For example, if we want to register routers or include the routers, we shall do it all from here. Then I'm going to create another file outside the source folder, which I'm going to call run server.py, and this is the one that we're going to run our server with UVCon. So UVCon is the web server that we're going to use in this video to run our FastAPI app. So what I'm going to do is to first of all install UVCon. So I'll do that with pip install UVCon, and that will go ahead and install UVCon within our virtual environment. Once we've installed UVCon, we're now going to go right here and import UVCon. And once we've been able to do that, we're now going to go ahead and run our app with if danda name is equal to danda main, then In this case, we're going to go ahead and run our app, but what we need is to go ahead and point to the module in which we've created our app instance. So in this case, if we are to call the run function on UVCon, we need to specify that we need to point to that source app instance. So for us to be able to do that, all I'll do is to go ahead and use this syntax of the module, which is source. In this case, it's a package, and then point to the app instance, or the ASGI, or the ASCII instance, which is our app instance. So what I'm going to do is to say app. So I'm going to call this source app, and in here, what I'm going to do is to basically specify our host to be our local host instead of having to use 0.0.0. So what I'll do is to come right here and say 127.0.0.1, and this is basically our local host, and then we're going to keep it to the default port, which is port 8000. It seems like VS Code is not seeing my packages, so if I'm to fix that, what I'll do is to maybe point to where it is. And now I see it's going to reload, and in this case it will be able to see my packages that I installed within the virtual environment. Can also go ahead and format this because I have the black code extension, and what it will do is to go ahead and use black to format my code. Now, away from that, we've been able to successfully set up our simple web server. So to run this web server, we're going to go ahead and pull up our terminal and then run Python run server.py, or python3 run server.py. So this will go ahead and run our app, and now when you go and navigate to that specific URL, we shall see that we do not have any item found, so it's going to return not found. So let's define a simple API endpoint. So to do that, what we shall do is to go here where we've created our app instance, and for us to just test, we can just say create a ping pong kind of endpoint. So in this case, we shall say app.get, and in this case, if I say ping, I want to just return an API response of pong. So app.get is basically when we use the app instance to create our HTTP method, we specify the route or the path that we want to navigate to get a response. And after doing that, then we shall define a function that is going to handle our response. So if I create that, it's just a simple function that returns a message of pong. In this case, if I navigate to the /ping endpoint, we shall see it's not found. So we have an issue, and that issue is arising because when we ran our server, we didn't specify it to reload on code changes. So let's change that. So for us to be able to do that, what I'm going to do is to add another argument to this run function, and that is going to be reload equal to true. So reload is always equal to false. So for us to set that, we shall say reload equal to true, and that will basically help us to reload our server every time we make changes to our code. So I'll restart our server, and once it's restarted, we can now go to /ping right here, and when we try to refresh, we shall now see that our simple message of pong is returned to us. Alright, so for now we've been able to create our simple web server. Let us go ahead and create a simple database connection. So for us to create a database connection, we have to do this in the right way. The right way to connect to a database is by using FastAPI's lifespan events, or startup and stop events. So basically, these are events that run at the beginning of your application and end when your application has been shut down. This may include things like, let's say, loading a machine learning model, or connecting to a database itself, or loading any other functionality that may take a lot of time to load every time a user makes a request. So FastAPI allows you to create that event, run it throughout the lifespan of the application, and then when the application shuts down, that event will also shut down. So for us to be able to do that, what I'm going to do is to go right here, and I'm going to create a new folder where we're going to create all our database stuff. So that's going to also be located within our source directory. I'll create a new folder which I'm going to call DB, and it's also going to be a Python package. So I'll just come right in here and say this is going to be our danda init.py. And in here, I'll create a new file, which I'm going to call main. So what we're going to use is SQLModel, which is basically an ORM that helps us to use Pydantic as well as SQLAlchemy to achieve both database functionality as well as validation. So what do I mean by this? We create models that are for our database, but the same models can be used to validate the data that we send via post requests, or validate the data where we need to make sure that it's the right data that we are sending to our API. And we're going to see how this works. So to begin, we're going to begin by installing SQLModel. So I'll open up a new terminal instance right here, and inside here I'm going to say pip install SQLModel. So once we've installed SQLModel, we're now going to go ahead and basically set up SQLModel. But before we do that, let us first of all create our lifespan event that's going to help us to connect to our database. So I'm going to go back to where we created our FastAPI instance, which is in this folder right here, or this specific file, which is init.py within our source folder. And what I'll do is to create that lifespan event. So the way we create that lifespan event is by using a context lib, async context manager, decorator. And this is how it works. So we have to first of all import our async context manager. So I'll say from context lib. So in this case, all we have to do is to import the async context manager decorator, and then we shall decorate a simple function with our async context manager. So in this case, we shall say at async context manager, we are going to create our lifespan event as our async context manager. So for us to be able to do that, we shall say async, we shall define a simple function and we shall give it a name of, let's say, lifespan. And what this is going to take in is going to be an app instance or a FastAPI instance. So we're going to provide one by saying app, and then we say that app is going to be of type FastAPI. So in this case, we shall provide our FastAPI class. And once we've been able to do that, all we have to do is to go ahead and define which event do we want to run when the server starts and which event do we want to run when our server stops. Now let's see how this works. So basically what you do is to define this function, and all you have to do is to provide the yield keyword. So for us to determine what code will run when our server is starting and what code will run when our server stops, all we shall have to think about is where to place that code. So all the code that is going to reside before the yield is going to be run at the start of our application, and all the code that is going to reside after the yield is going to run when our application has stopped. And let's look at how that works. So if we come right here and say, let's say print server is starting, sorry for this. So if we say server is starting, in this case, this code is going to run when the server is starting. So if we say server is shutting down, then this code is going to run when the server is starting down. And therefore, we shall run our database connection code right here, and we shall also run whatever we want to run when the server is shutting down below the yield statement. So let's go ahead and set that up to work with our FastAPI application. So to do that, inside our FastAPI instance is where I will go ahead and provide all that. So we have all these suggestions. I'm using Tab9, which is an AI auto-completion tool, and it helps me to generate these. So in here, I'm just going to remove all these because I don't need them. Maybe I'll keep the title, and I'm going to basically call the title, let's say, book service. And once I've been able to do that, then inside here is where I'm going to go ahead and provide our lifespan event. So to do that, shall basically provide a very important argument, and that's going to be the lifespan argument. And what this is going to take in is the function we have defined right here as our lifespan function. So I'm just simply going to go ahead and provide that. And that's just enough for us to run our lifespan events. So to demonstrate this, I'm going to save, and what I'll do is to stop our server. So I'm just going to basically press Ctrl and C, and I'll start our application once again. So in our application is starting, we shall now notice that our server is starting. So this code is going to be run before the server starts. Now, if we stop, we're also going to notice that this code is going to be run when our server is stopping. So that's just an easy way for us to be able to determine what code we want to run or which task we want to perform when the server is starting and when the server is shutting down. Now that we've been able to set that up, let's go ahead and set up our simple database connection to PostgreSQL. Now we're going to be building a simple REST API for a books service, basically a CRUD API. But in this CRUD API, I want to explore the different functionalities of SQLModel. The first step for us is going to be to create our simple database. So to create our simple database, all we're going to do is to go to our terminal window right here. So in this terminal window, I'm going to log into my PostgreSQL. So if you do not have PostgreSQL installed, you may need to install it. And just in case you have it installed, then you can follow along and you can be able to create your database as I'm going to do. You may also use tools like Neon that help you to get a serverless PostgreSQL database that you can easily plug in. All you need to is to get the URL and you'll be good to go. So in this case, what I'm going to do is to first of all log into, or basically log into my Postgres user. So to do that, I'll say sudo su, so super user, and in this case, I'll point to the user Postgres. So I'll put in my password, and that will basically log into the user Postgres. And once I'm inside the account of the user Postgres, in this case, all I have to do is to access my PSQL shell, and right there, I am inside my Postgres shell. So all I have to do is to create a simple database with a create database function, and this is simply going to go ahead and create our database. So I'm going to go ahead and give this a name. I'm going to give this a name of, let's say, books service. So I'm just going to call this book service DB, and that will create our database. So once we've been able to do that, then let's go ahead and determine how we're going to connect to our database. Now, to keep our database URL separate, I'm going to be using an env file, and we're also going to explore Pydantic settings, which is basically a tool that works with Pydantic to help you read and manage your environment variables. So I'll just come right here, create a new file. I'm going to call this .env, and within our .env, I'm simply going to create one environment variable, which I'm going to call the database URL. Let me just call this the Postgres URL. So I'll just say Postgres URL, and in this case we are going to create it. So depending on what you're using, this is not going to be the same for you. So for me, I'm going to use something like PostgreSQL. So since I want to access this with an Async DB API or with an Async dialect, I'll have to specify that I'm going to use Async PG, which I have not yet installed, but I'm going to install. So I'll say PostgreSQL plus Async PG. In this case, we shall now specify our user to be Postgres. And in this case, we shall, so this is supposed to be Postgres, and then we shall provide the password. So my simple password is this. Please, this is not your password, so keep in mind that you have to create your own database URL. So I'll specify that this is going to be for localhost, and then I'll define the default port for PostgreSQL, which is port 5432 / the database that we created right here, which we called our book service DB. So I'll just copy it, and then I'll go ahead and paste it right here. So for now, we've been able to set up our database URL as an environment variable. So If we want to go ahead and read this from our environment variable, we're going to use Pydantic settings, which is basically a tool that works with Pydantic to help you manage your environment variables. So to begin, I'm going to go within our folder, within our source folder right here. And inside our source folder, I'm going to create a file that I'm going to call our config. So config is where we're going to keep all our environment variables. And to do that, we're going to create a Pydantic model that is going to help us achieve that. But before we do that, we have to first of all install our Pydantic settings. So I'm going to go to our terminal right here, and all I have to do is to go ahead and install Pydantic settings with pip install. In this case, we are going to install Pydantic -settings. Once you've been able to do that, this is going to collect and install Pydantic settings. And once it's been able to do that, we are now going to go ahead and read our environment variables. To read the environment variables that we put in env files, JSON files, toml files, and so on, we use the base settings class that comes from Pydantic settings. So to begin, we are going to go ahead and import that. So we shall say from Pydantic settings, we are going to go ahead and import our base settings class, and from our base settings class we're going to create an instance of it by basically saying it's going to be an instance of the base settings class. In here is where we go ahead and simply read the names of our environment variables and provide them as attributes to the settings class. So we're going to go ahead and set our Postgres URL and basically provide it as an attribute to this base settings class. In there is where I will also go ahead and define the type of that specific environment or that specific setting that we want to read. So in this case, it's going to be a string, and then we can also go ahead and do other extra validations. But this is just enough for us to be able to describe our environment variables. Now, to read this environment variable from our env file, we are going to need to tell Pydantic settings that we need to read this from an env file. And the way we can be able to do that is by using the model config. So every Pydantic class or every Pydantic model you will create will come with a very important attribute, which is the model config. The model config is where you will go ahead and set up all the configurations that you need for that specific model. But in this case, we need to configure this base settings class, which is a Pydantic model, into one that's going to be able to read environment variables from our .env file. And the way we're going to do that is by using a special class that Pydantic settings provides that is called the settings config dict. Now the settings config dict is something like settings configuration dictionary, where all the settings that all the configurations to the settings may happen. So let's go ahead and import that. So to do that, we're going to go ahead and also import our settings config dict. And once we've been able to do that, then we're going to go ahead and modify the model config of this Pydantic class to point to an instance of our settings config dict. Now, if we go ahead and explore this settings config dict, we shall notice that it's going to have a bunch of customizations or a bunch of configurations. In there, we have the env prefix, which is basically the prefix of the environments that we may want to read. The env file, so that will point to the env file from which we want to read our settings. We also have specific other specific files, for example, JSON file or YAML file. That's if you want to read from a YAML file, you want to get your environment settings or your settings being read from a YAML file or a toml file, and so on. But in this case, we are using an env file, so we shall just come right here and say env file, and this is going to be our .env. And once we've been able to do that, we can now also just in case you want to provide the file encoding, then we can go ahead and do that by providing the env file encoding attribute to this instance right here. So I'll just go ahead and close that. Then one important other attribute that we're going to provide in here is basically to prevent the reading of extra inputs, and the way we're going to do that is by setting our extra to ignore. So this is something that I encountered when creating this video, where whenever I did without having to provide this, I got the error where Pydantic was basically not allowing me to read extra inputs to this specific settings class. So once I've been able to do that, then the next thing is going to be to just simply create an instance of this settings class. Now when you go right here at the bottom of our code, you can just say settings, which is going to be with a lowercase s. It's going to be an instance of our settings class. And once we've been able to do that, if we go ahead and let's say print our settings, so since this is a Pydantic settings or a Pydantic class, we can just simply call the model dump function. Now this model dump function is just one that came in with latest versions of Pydantic, where it will just simply print a dictionary representation of whatever attributes that we have within our settings. So let's go ahead and look at how that works. So I'm going to go within my terminal right here. So just going to close some and open another one. And within here, all I have to do is to say Python 3, and then I'll point to our source and then config. So I'll just say source config.py, and now we shall see that this is going to print a dictionary where we have a key being our Postgres URL, and the value is going to be our URL as we defined it within our env file. So that is good. We've been able to read our env file and basically get to access the database URL that we set up earlier on. So let's go ahead and try to create a database connection to that specific database. To do that, we're going to go back to our DB folder right here, and within that DB folder we created a main.py file from where we're going to connect to our database. So SQLModel works with SQLAlchemy and basically provides for us a very similar way to connect to our database. To do that, we shall have to first create an engine object, which is the one that's going to help us to create a connection to our database. In that engine object, we can also go ahead and define other specific variables or other specific attributes that will help us to interact with our database in a very specific way. To create a database connection, the first thing we're going to do is to head over to our main.py file, the one that we created inside our DB folder, and that's where we're going to first create our engine. Now this functionality is similar to that of SQLAlchemy. However, we are going to approach it using an async approach. So what we're going to do is to go within our main.py, and we shall first of all begin by creating an async engine. So for us to be able to do that, we are going to use SQLAlchemy's async engine class, or we're going to make use of the create async engine function that comes from SQLAlchemy, so that we directly create an async engine since we are using an async DB API. So for us to be able to do that, we shall say from SQLAlchemy, we are going to go ahead and import our so this is actually going to be from our SQLAlchemy async IO extension. So in this case, shall say from SQLAlchemy.async.ext.async IO, we shall import the create async engine function. Now we're going to go ahead and use this by creating an engine, and this is going to be our, let's just actually call it an async engine. So with this, we can simply call our create async engine function, provide the URL. Now we already set this up within our settings, so all we have to do is to import our settings object. So we shall just say from source.config, we are going to get access to our settings, and once we've been able to do that, we have to just define our URL as settings dot, in this case that will be our Postgres URL. So just going to get access to our Postgres URL. And once we've been able to do that, then we shall also provide other attributes such as, so in this case, we are going to basically provide echo equals to true, so that you can see all the SQL that will be logged with every transaction we carry out. So that will be equal to true. And once we've been able to do that, then the next thing we're going to do is to try to test this connection using SQLModel. So the way we're going to do this is by creating an async function or a coroutine, and you're just simply going to call this initDB. Now initDB is what we're going to run at the start of our application so that we establish a connection to our database. So for us to be able to do that, we are going to make use of this async engine object we've created right here with SQLModel's session object. And what that will help us do is to be able to create a session, and when you create that session, we shall use it to execute a simple SQL statement on our database. So to do that, what I'm going to do is to go right at the top right here, and all I'll say is from SQLModel. I don't know why I keep writing SQLAlchemy, but this is going to be from SQLModel. So we are going to get access to the ext module, and then within async IO, we are going to import the async session object. So this is going to be our async session. And once we've been able to get this async session, this is actually not going to be from ext.asyncIO, but it's going to be from ext.asyncIO.session. Just forgot this, but once we have this, then all we need to do is to go ahead and create the session object using our async session. So to do that, what we're going to do is to simply use an async with statement, and in this case we shall basically provide our async session. So this async session will take in the object, so we can just say this is going to take in our async engine, and we can say this is going to be our session. So we're going to create a simple SQL statement, and this is going to be something like, let's say, a statement. Now keep in mind that some of these are got from SQLAlchemy, so if we create a statement, we shall wrap it within the text function so that we can be able to execute it. But we can go ahead and also import that from our SQLModel. So to do that, we can say something like from SQLModel, we are going to go ahead and import our text function. And once we've been able to do that, then we can now go ahead and simply execute that statement. So for us to be able to do that, we shall say text, and this text function is going to take in the SQL statement that we want to do. Now in this case, to just test the connection, we're just simply going to say select, and then let's say hello. So what this will do is to just print hello in our console. So I'll just say select hello, and that will be it. But for us to be able to get the result, we shall have to first execute this using our newly created session object. So we shall create a variable called result, or even without running the result, or let's say we can wrap this in a result. So we can say result is going to be equal to executing the execute method on our session object, which is going to be a coroutine, and that's why we are using await. So if we say something like session dot execute, in this case we shall execute our statement, and right now we see that this is going to be deprecated. So instead of saying session.execute, we are being want to use session.exec. So let's change that. So I'm going to get rid of this and this session.exec, and then we shall pass in our statement. Now all we can do is to just simply print our result, and that will be just enough to test our database connection. Now if you want to see this working, what we should do is to go to where we created our FastAPI instance and wrap this within our async context manager lifespan function that we created at the start of the video. So to do that, I'm going to head over to our source directory, and within our source directory, inside the under init.py file, that's where we created our FastAPI instance and our lifespan function. So just right there is where we're going to basically call our initDB function. So to do that, I'm going to go ahead and first of all import it. So I'll say from source.db.main, we are going to have to access our initDB function. But keep in mind that this is a coroutine, and therefore if we were to call it, we'll have to call it with await, and also have to call it within an async function or a coroutine. So we're going to do that by saying await, and in this case we shall say await init db, and that will be just enough for us to run our server or connect to our database. So if we save, our server is going to restart, and in this case we shall see that some SQLAlchemy, some SQL statement is being basically executed. And if we are to notice, we basically see begin, and our select hello is going to be executed on our database, and it's going to print our result object, which is basically this result object here. So if we want to see the result, what we can do is to go ahead to where we created that specific init db function and then say result.all. So if we save, this is going to go ahead and basically print the hello that we actually selected from our database. So we've now successfully created a connection to our database, and we are now going to go ahead and simply create our database model that we are going to carry out our create, read, update, and delete functionality. To create our database, we are going to need a database model, and we're going to create it within our db folder right here. So I'm going to add a module called models.py inside our db package, and within this model is where we're going to create our database models. So to create our database models using SQLModel, the first thing we're going to do is to first of all import the SQLModel class. So for us to be able to do that, we shall say from SQLModel, we are going to go ahead and import our SQLModel class. And once we've been able to create that SQLModel class, we are going to create our database model class by simply creating a class that subclasses the SQLModel class. So our database is going to keep books, and therefore I'm going to create the model as book. Why? Because database model names are always written as a singular name. So in this case, I'm going to go ahead and basically provide the class that is going to subclass, which is the SQLModel class, but keeping it to just SQLModel is not going to be enough for this table to be a database table. So for us to be able to make it a database table, we shall provide one extra attribute that is going to be the table attribute. So we're going to come right here and say table is going to be equal to true. And once we've been able to do this, then we are going to go ahead and define a name for the table that's going to be in the database. So we do that by providing the SQLAlchemy table name attribute, which is the Danda table name. So in this case, we want the table name to have a plural name, which is going to be books. So we've created our model as books, but the table in the database will be books. Once we've been able to do that, we're going to define an ID, but we want this ID not to be an integer, but to be a UUID. So for us to be able to do that, I'm going to define the UUID being equal to a UUID. So I'm going to come right in here, and I'll have to import the UUID type from the inbuilt UUID module. So what I'll do is to say from UUID, I'm going to go ahead and import UUID. And once I've been able to do that, I'll just come right here and provide the type as UUID. But one thing I want to do is to make this field an SQLAlchemy primary key. So for me to be able to do that, what I'll do is to first of all make this a field. So for me to make this a field of Pydantic, I'll have to go and basically import the field class from SQLModel, or the field function. And this field function is what I'll use to provide the SQLAlchemy database related attributes. So inside there, I'll just simply come and say SA column. So just like we define an SQLAlchemy column, SQLModel provides for us the field function that has the SA column, which is the SQLAlchemy column. And inside this column, we can go ahead and define the specific attributes we want to give to a certain field. So in this case, we want to go ahead and make this UUID field. So for us to make that an SQLAlchemy column, we have to first define it as a column and then provide the different attributes or the different things that we want to provide to that column. So for us to do that, I'm going to go right here, and all I have to do is to say we're going to import the column class, and inside the column class we are now going to go ahead and basically create this as a column. So we shall provide the different things such as the type, whether it's a primary key or not, or if you have any other constraints, we shall just add them onto this column instance. So the first one we're going to do is to provide the type. So I want this to be a UUID in our PostgreSQL database. And for us to make it a UUID, what we'll have to do is to define this as a UUID type column. Just like we define columns as text, as integers, as big integers, we may also need to define this in our PostgreSQL as a UUID field. So for us to do that, what I'm going to do is to first of all import our UUID type from SQLAlchemy. But for me to do that, I'll say from SQLAlchemy.dialects. In this case, I'm going to go to the PostgreSQL database, or the PostgreSQL dialect, and I'll actually just import it. So I'll just say import this as PostgreSQL, or I'll just simply make it be something like PG or PSQL, whatever it is. So once I be able to do that, then I have to access the type, which is going to be our UUID type. So once I provide that UUID type, one thing we can notice is we have various types in here. So we can get the char, the array, the JSON types, the big int types, all the types that are associated with the PostgreSQL database are going to be present. So in case you need to store a JSON, you'll still have to access it from here. But all we need is going to be the UUID. And once we've been able to do that, we have been able to provide the type. So we can go ahead and also provide other attributes. So in this case, we want this to be our primary key. So we can just say that our primary key attribute is going to be equal to true. And we are also going to go ahead and provide our unique equal to true, because we want this to be a unique since it's going to be a primary key. Then once we've been able to do that, then we can also provide a default. So let me put this on a new line. So our default in this case is going to be our default, our newly created UUID4. So every time we shall create our book, we expect that we want to automatically generate a new UUID for that specific book. So once it's done, I'll just simply go ahead and I'll import the UUID from UUID. So I'll import the UUID4 function from UUID that's going to help us to create a new UUID. So I'll do that with UUID4. And once that is done, I'll just simply come right here, and then I'll just provide a default. So our default is going to be our UUID4. And that will be just enough for us to have our primary key created. Now we're going to have other attributes on our books, and every book is going to have sort of like a name, or let's give it a title. So the title is going to be a string, which can be a text, but we can keep this out for now. We can just simply keep it simple by providing the attributes. We can also have the author, which is going to be a string. We can have the ISBN, but yeah, let's just have the ISBN, which is going to be a string. Now, we are also going to have the description of the book, and after we shall have the created at date. So the created at date is going to be a datetime object. So I'll have to go ahead and import the datetime class. So I'll just do that from datetime import and datetime. So one thing that is important to notice is the UTC now function or method is now deprecated, and we need to use something that we need to use another approach of creating these date times that doesn't use the UTC now. So in case you want to provide, or you want to create a datetime object that has a timestamp, all you need to do is to provide the datetime.utc within your now function. So for us to keep it simple, all I'm going to do is to come right here and basically say UTC remove the UTC, replace it with date.now, and then I can even maybe add an updated at, and that will be the same thing. So this is just a simple model we've created right here. Now to make this interesting, we can also go ahead and say danda repre self, and this will return this is going to just simply go ahead and return the string representation of the database model object that we shall be querying. So in this case, we can just say simply book, and then we shall basically point to the title of the book. So we can just say self.title, and that is just enough for us to create our database model. Now let us go ahead and create this table in our database so that we can be able to finally do the CRUD on it. So for us to be able to do that, I'm going to go where we created our initDB function so that we can be able to finally create these tables in our database. So I'll head over to main.py within our DB folder, and what I'll do is to change initDB so that every time it's executed, we go ahead and initialize these tables in the database. So what I'm going to do is to go ahead and first of all import our models. So to do that, since it's within the same folder, we can do something like from models. We are going to go ahead and import our model class, which is book. And once we've been able to do that, then we are going to change the code that is found in here so that it just helps us to create our database. So whenever we're using SQLModel, whenever we're using SQLAlchemy and you need to create tables in a database, we first of all have to create a metadata object out of the base class that we use to create our object. So we used to create our model classes, but SQLModel saves us from that, and it helps us access the metadata object from within the SQLModel class. So for us to be able to do that, all we have to do is to import the SQLModel class, and we shall just say import SQLModel. And once we've been able to install the SQLModel class, now we're going to go ahead and create our database tables. So what I love to do in most cases is to import the models from exactly where we are creating our database. Why? Because sometimes there's a habit of having to ignore all these database models, and therefore even when you run the create all function, the tables are not created in the database. We are now going to go ahead and basically create our database, but we're going to have to change this because we're not going to make use of our session, but we're going to make use of our engine. So it's the same thing. It's going to be async with, but instead of creating a session, we're going to basically first of all connect to our database. So we shall say with async engine dot, in this case we shall basically call the begin function as our connection. In this case, we are going to await or call the run sync. So even the AI is actually showing it to me. So what we're going to do is to call the run sync function. So run sync is a function that can help you run those methods that are synchronous in the context of your async DB function. So for example, the SQLModel.metadata.createAll function is a synchronous function, and therefore that's why we have to use the con.runSync function to run it. So having to run this will automatically create the tables in our database. But for us to be able to do that, what I always do is to go ahead and provide the model that we want to create in our database. So if I go ahead and save, our server will restart, and once it restarts, then we are going to go ahead and create our database. So if we go ahead and run our server once again, so it seems like I have an error right here. That error actually came from the silly mistake I did where I defined the width not as async, and therefore the server had to throw that error and stop us from running. So what I'm going to do is to just simply change this to async with. So with async, so basically what we're doing is to create a context manager with async, but we did not provide the async, and that's why it threw that error. So when I provide the async right here, our server is going to start, and since we have now created our database, we have now seen our SQL being logged right here in our terminal, which is beautiful, which is awesome. And this is a very good way to create our database connection. So we've created our database connection. We've been able to create our database tables in the database. So let's go ahead and confirm that. I head over to our terminal window where we created our database. So if we go ahead and connect to that specific database, which we called books service DB, you're now connected to it. So let's display some tables, and now we have our books table created right here. So if you go ahead and let's say try to list some information or describe that specific table, we shall do backspace D, and then we provide that specific table, which is going to be our books. We shall now see that our tables have been successfully created. We have our UUID, we have our title, we have our author, our SBN, our description, created at, updated at. This is beautiful. We've successfully created our database tables. Now let's go ahead and try to make use of this database table we've created by using SQLModel to create API endpoints, so FastAPI, that allow us to expose our database and help us to carry out some functionalities on this simple book database. So to do that, I'm going to go ahead and first of all close that, and we shall head over to our FastAPI. So for now, we've been able to set up our connection. Now the first thing we're going to need is to share the state of the session we shall use to carry out these specific CRUD functionalities, and that's where dependency injection comes in. Now if you don't know about dependency injection, please check the video I'm going to put at the top. It's going to kind of give you an introduction to dependency injection. But basically, dependency injection is one of the ways in which you just pass one variable or one state from one API endpoint across many other API endpoints. So that's what we're going to need. So we're going to need a session that we're going to pass in to all the other sessions so that we can easily do our CRUD. So let's go ahead and look at how we can do that. Once we have been able to do that, we are now going to come right here and say that this is going to return an async session object. Once we've been able to do that, now let's go ahead and create a simple async session that we're going to return and use within our API endpoints. So for us to be able to do that, we shall say that our async session is going to be a session object, but for us to create this, we shall need a very good way to create it. Now, one of the ways of creating a session is by basically creating an instance of the async session, but there's a better way to do that, and that's by using the session maker class that comes from SQLAlchemy, as we're going to see. So if I come and say from SQLAlchemy.orm, I get access to the session maker class. This is the base class from which all session objects are created, and once we have access to this class, we can therefore create any session object that you may want. So if we go ahead and say that this async session is going to be an attribute, it's going to be an instance of the session maker class, we can then go ahead and specify the engine to which we're going to bind this session, which is going to be our async engine that we created. So we shall say that our bind is going to be equal to our async engine that we created. And once we've been able to do that, we are going to pass in one special attribute, which is going to be the class attribute. Now this class attribute is what is going to basically talk about the type of the session you're going to create. Now you can choose to create a synchronous session or an asynchronous session, and in this video we want to use an async session. So what we're going to do is to just basically state that we want to create an async session or a session object of type async session, and this is just a brilliant way that I kind of learned of when basically browsing around. I read this from testdriven.io. I cannot recommend them enough. If you haven't checked them out, please do. But they do a very good role of basically creating content around using tools such as FastAPI. So once we've been able to create our async session, we're now also going to pass in one very important attribute, and that's expire on commit. So expire on commit, we are going to set this to false simply because we do not want to expire a session once we've been able to commit something on our database. Simple as that. So once we've been able to do this, then we are going to go ahead and pass this around. So to pass this around, we shall just say with this session object, or with, because this one is a class right now, and once we create this class from our session maker, then we're going to go ahead and first of all instantiate it or create an object of that class. That's why I pass in these specific brackets right here. And once I've been able to do that, then we are simply going to call that newly created object our session, and then shall finally pass that session onto any other parts of the application. You may use it with yield session. What we've done here is to just create a dependency, which is our get session function, and what this dependency is passing on to the dependent API endpoints is going to be the session object, just like we're going to observe. So once this is done, then let's go ahead and define our API endpoints. So defining our API endpoints is going to be as easy as creating a new folder within our source directory. We shall call this folder books. And we are going to mark this as a package by simply coming here and creating a new file that we're going to create our that we're going to call our init.py. And within our init.py, we are now going to go ahead and pass in the name of the routes.py file, in which we're going to create all our API endpoints that are specific to the CRUD or the books or any further functionality that you want to add to the books package. So we are going to keep this modular in a way that all the API endpoints for a specific place will be found within a specific place. For example, API endpoints that are specific to books are going to be found within the books package, within the books folder or directory. API endpoints that are specific to auth, if you are to add the auth, which I highly recommend, are also going to be found within the auth directory. So what I'm going to do is to come right in here, and I'll say from FastAPI, we are going to go ahead and import the API router class. Now, this is basically one way in which you may structure a large project. You simply have to create various routers for various related API endpoints. And once you've been able to do that, then we're going to create a book router object. And this book router object is going to be an instance of our API router. Now, this book router object is going to be similar to our FastAPI instance, as it's going to allow us to create our API endpoints. So to do that, we're going to say at book router. So in this case, I'm going to basically create the first endpoint, which is going to be reading books, but this is going to use our session, and therefore we have to inject it. So what I'll do is to go ahead and import our session by, first of all, which is actually our get session function. So I'll just do this by saying from source.db.main, we are going to get access to our get session function, and we have to inject it to all CRUD API endpoints because we are going to be using our database to basically we are going to be using our session to access our database in all API endpoints. So I'll just come right here and say session, and this session is going to be a result of, so this session is going to be an object, but it's going to be an object of type async session. So I think I'll also need to access the async session. So what I'll do is to say from SQLModel dot, in this case, ext.asyncIO.session, we shall import our async session. So this is going to be our async session, and what I'll have to do is to just say that this is going to be of type async session. Now, if you're not familiar with this, what I'm doing is to specify the type using type hints, as FastAPI mainly depends on type hints to basically validate whatever you have to pass through the API handler functions or the path handler functions. So what we've done here is to basically provide or inject a session object, but for us to go ahead and do the actual dependency injection, then we'll have to use the depends function that comes from FastAPI. So I'm going to go ahead and import that from FastAPI, import depends. And once you've been able to do that, then we're going to go ahead and say that this is going to be a dependency, and it's going to be a dependency from the get session function. And this will allow us to access all our session objects. Now let's go ahead and pass this for now. We are going to implement this one by one, but what I want to do, or what I prefer, is to go ahead and go create all these API endpoints. Then we go ahead and try to do each one of them one by one. So what I'll do is to just go ahead and first write the API endpoints, and then go ahead and write the CRUD stuff, then just go ahead and fill it within the API endpoint. So let's begin by first of all creating the next one, which is going to be the one for creating. So when you're creating, we expect to have a post request, and this post request is going to be to the same API endpoint for the creation of our books. Now, one thing we're going to pass in here is going to be the status code that is going to be returned in case we successfully create a book. And in this case, we are going to pass in the 201 status code. So the way I prefer to do this is by basically going ahead to access all the HTTP statuses from Python's inbuilt HTTP status class. So that's present within HTTP, or within the HTTP module. So if we want to access the statuses, then we shall say from HTTP dot, in this case we have cookies, server, and a lot of other things. So in this case, we want to access the HTTP status class, and from that HTTP status class, we want to go ahead and basically access the OK status code. So shall just come and say import the HTTP status code of OK, and that will be just enough to provide the status code to be returned. But I actually made a mistake. This is supposed to be our created status code, which is 201. So I'll have to change that to created. So now let's go ahead and define how we're going to create this. So our function for handling the creation of the books is going to be called createBook. I see the AI is trying to be AI, or I don't know if that word even exists. So in here, we're going to first inject our dependency, which is our session, and this session is going to be of type async session. I guess I'll have to just copy it and paste it within every function that's going to depend on it. So I provide it here, and then one thing that we also need when creating our books is going to be the data that's going to come from our API. But let me leave that out for now. I think I'm going to deal with it later. So I'll just pass it for now. So let's go ahead and create the other API endpoints. So we're going to have one for getting a book by its ID. So I'll say bookrouter.get/book ID. So the status code is going to be OK. And in this case, we're going to read the book by its ID. So we're going to pass in a book ID, which is going to be of type UUID. Or to keep it simple, we can even say type string. And then we shall have to query it as a UUID when doing the actual querying. So I'll just pass in the UUID, and then we shall basically also inject our session. So we shall pass this for now. Now the rest of the endpoints for CRUD are going to be very similar to this one. So I'm just going to go ahead and copy paste it, and copy paste it until we'll have those for updating and deleting. So what I'm going to do is to just come right here and say that we are going to update a book by its ID. So this method will change from get to put, and then we shall also change this from get to delete, also having to change the delete, or changing the name of the function that handles this to delete book. Now in here, I'm also going to determine or write the status code as HTTP no content, because after deleting something, we expect that we are not returning any content. So our API endpoints have been written and they are here. It's just simple CRUD stuff, but you can feel free to add some functionality onto this. So Once we've been able to add these API endpoints, the next thing we're going to do is to register these on our application. So to register this on our application, we shall have to first of all determine the prefix on which all these API endpoints are going to be found. Now, using routers allows you to group related API endpoints or paths onto a single prefix. So in this case, if we want to basically put all this on one prefix and basically make them related in some way, we shall have to define that by using the prefix argument to our API router instance. So our prefix in this case is going to be the slash, this is going to be the slash books prefix, and that means that all API endpoints that are going to be present on our book router are all going to be accessed via the books prefix. So once we've been able to do that, now let's go ahead and include this in our main FastAPI instance. So I'll save, and when you go back to where we created our FastAPI instance, which is in our source directory, shall head over to our init or danda init.py file, and within our danda init.py file, we shall now go within our FastAPI instance, or not actually within our FastAPI instance. So I'm going to get rid of this specific API endpoint, and then we shall have to use our app to register our router or to include the router. So to do that, we shall just say app.include, and then we shall just basically register our this is going to be the app.include router method. I don't know why I keep on forgetting it. And then we shall have to provide the router. So if we go ahead and import the router, we shall say from source.books.routes. In this case, we are going to go ahead and import our book router. So once we've been able to do that, if we go right here, we shall now go ahead and include it as our book router. Now inside here, we can also go ahead and add other things. So for example, if we wanted to add tags, so tags can also be used to group the API endpoints when using the Swagger UI that we're going to look at in a minute. So if we say tags, tags is going to be a list of tags, but let's say all books are going to have the tags of books. So I'm going to save, hoping that our server is still running, of which it is. Let's go to our browser right here. We shall now go ahead and access our docs URL. So that's going to be on the docs URL. And now we have our API endpoints created right here, which is sweet. So I have a description that's not the actual description for our UI, so I'll have to change it. So I'm going to go where we have our API, FastAPI instance, and then I'll have to change it from a simple example of a FastAPI application to a simple web service for a book application. So yeah, that is just enough for us to basically change our description. All right, now let the games begin. Let's begin implementing our simple CRUD. So to implement our CRUD, we are going to go where we basically have our file. To keep our API endpoints organized and not crowded, I'm going to implement what is called a service file, in which we shall have all the functionality for our CRUD. And within that service file, we shall do the things, we shall create various functions which we shall have to access and call directly within our API endpoints without having to define everything from within our API endpoints, therefore making our API endpoints have less code. So let's get to that. So what we're going to do is to go to our books folder right here within our source directory, and we're going to begin by creating a service file. So this service file is going to be called service.py, and within our service.py file, we are going to go ahead and create a class that we're going to call our book service. Now this book service class is the one that's going to help us to be able to basically carry out all our database specific things of managing books. So to do that, I'm just simply going to create a class that I'm going to call the book service class. And once I've been able to do that, then I'm going to create a danda init function or method that's going to be the one that's going to be run every time we shall create a book service object. So we're going to be creating a book service object, and that's where we shall access all the methods that we're going to define for managing books. So I'll just come right here and say def init, and in this case we only have self, but one thing I want to do is to provide the session object. So this session object is going to be of type async session. So for me to simplify my life, I'm going to use type annotation. So I'll say from SQLModel dot exec dot async io, which is actually .ext. Forgetting this. So this is going to be .ext async io session. I'm going to go ahead and import the async session class, and once I've imported that, I'll simply go ahead and annotate this to be of type async session. So when you're creating our book service object, we shall be passing in the session. So I'll say that our self.session is going to be equal to the session that we have right here. So that means every time we shall create a book service instance or object, we shall need to pass in the session that we're going to use to query our database. Now that that is done, let's go ahead and define the functions that are going to help us to basically be able to query our database and manage book resources. So we're going to begin with one for getting all books. So we shall call this async def get all books, and this will take in self as well as, so this will actually take in all self because it doesn't need anything. So you have to first of all define the statement for getting all books. So for us to be able to do that, we will import the select statement from SQLModel, and to do that we shall say from SQLModel we shall import our select function. Once we have our select function, we shall now go ahead and basically get all books from our database. So we're going to create a statement, and this statement is one that's going to help us to get all books. So shall say select book, and this is actually going to need us to get our book model, which I haven't yet imported. So let me go ahead and import it. I'll say from source.db.models, we are going to go ahead and import our book model. So once we've imported our book model, now we're going to go ahead and say select book. This is actually book. So this is just enough for us to select all books. By doing this, what we've done is to execute the statement select stuff from books. So if we want to add other functionalities such as ordering, then we can say something like select stuff from books dot order by, and in this case we're going to order them by the time they were created. So in this case we want to say book dot created at, and that's just enough for us to order them by the date they were created. Now let's go ahead and execute this. For us to execute this, all we have to do is to create a result, and this result is going to be a result of using our session to execute this statement. So we shall say self.session.execute, and in this case we shall provide our statement. So this is going to be our statement. So if we want to get our results, then SQLModel's way of getting results is really easy. All you have to do is to get the result and then get the other methods that are to help us get all results or filter by whatever criteria we may want. So in this case, we shall say return, and then we shall say return result dot all, and that is going to be just enough for us to get our results. Now let's go ahead and make use of this within our routes. So what I'm going to do is to go to our routes file right here, and then within our routes I'm going to go ahead and import our service. So I'll just say from dot service we are going to go ahead and import our book service. And once we've imported this, then let's make use of it. So what we need is to make use of our session. So shall say book service, or let's say our books are going to be equal to our book service So this is going to be our book service, and in this case we shall need a session which we're going to pass in. Then in here we shall basically call that get all books function or method, and that will be just enough for us to get our books. Now for us to return our books, all we have to just say is return books, and that will just simply be enough for us to return our books. Now what if we want to dictate which kind of response we want to return? In this case we want to return a list of books. Now this is where Pydantic comes in. Pydantic allows us to determine how we want to return these books, or even help us to determine which kind of input we are passing to our API. Now in this case, we want to go ahead and basically specify that this API endpoint for getting all books is going to return a list of books. The way we're going to do that is by creating Pydantic models on top of what we have as our database model, since this is both a Pydantic model and an SQLAlchemy model. So to do that, I'm going to go ahead and create a file inside that DB package or module, and I'm going to call this schemas.py. Inside schemas.py, I'm going to go ahead, and what I'll do is to import our database model, because that's where we're going to get all our fields. So I'll just come right here and say from, this is going to be from our source dot, in this case it's going to be our source.db.models. We are going to get our book model, and once we've imported our book model, now I'm going to also go ahead and import the base model class from Pydantic, because we may need it also. So we're going to say import base model. So once we've imported that, then let's go ahead and first create the class for getting all books. So we're going to call this the book response model. This is going to be specifically for retrieving items from our database, and this is going to be a subclass of book, because all we need is to go ahead and access all the fields that exist on our book database model. So once we've done that, all we can do is to say pass, and that will be just enough for us to get all those fields. And we also need to create a class that we're going to call the book create class, and this book create class is the one that's going to help us be able to create a single book. So we shall just say book create model, and this is going to inherit from base model, but it's going to only have fields that are going to be used to create a book. Now I'll just copy those and provide them on our schema class. So this is going to be just like we have here. So once I've been able to do that, now let's go ahead and import this in our routes. So I'll just come right here and say from dot service. So in this case I have from dot service. Now I want to also say from dot where did I create that file? I think I created it. Where did I create the schemas file? I created it inside DB, but it's supposed to be within books. I'm sorry for this, so I'll have to move it. And when I move it, now I'm going to go ahead and import it from .schemas. I'm going to go ahead and import the book create model as well as the book response model. So once that is done, I am now going to go ahead and make use of our book response model by simply going ahead and defining that this API endpoint for getting all books is going to return a list of book response model items. So it's going to serialize them and turn them into the data type or JSON format. So what I'll do is to say that this is going to have a response model, and this response model is simply going to be a list of, let me put this on a new line so that you guys can clearly see it. So this is going to be a list of response model objects. So for me to do that, I already have the typing list class, and I'll just have to say list, and this will be a list of response of book response model objects. So let's go ahead and test this. So I'm going to be using Postman, so I'm going to go ahead and open up my Postman right here. So right here in my Postman, I have created a simple book collection, and I have API endpoint for, or an HTTP REST for getting all books. You guys will forgive me, I'm kind of tired. So let's try to test it. So when you try to get all our books, hoping that our server is running, of which it is. If we try to get all books now, we're going to get a server error. So let's check it out. So I think we've forgotten to await something, and that's what we are being told right here. So I think that is the book service.get all books. So we shall have to await, and once that is done, our server is going to restart. If we try to get all books once again, we're now going to get an empty list of books. Our API is functioning, we are working. So let's go ahead and try to create a book. So we've created our schema class, which is one for creating all books. So we're going to need this when creating a book. So what we're going to do is to go ahead and inject the payload that you're going to get from this post request right here into this API endpoint, so that when a user makes a request, we are able to validate the data they are going to send through the request. So the way we're going to do that is by simply going ahead, and so I'll put this on a new line. And what we shall do is to go ahead and get that data that's going to come from the users via the post request. So to do that, we shall basically call this the book create data, and this is going to be of the type of this book create model that we created. So once a user makes a post request, they're going to submit data in that post request, but it's going to be validated by the book creator model that we have created right here. So we can also go ahead and add other things such as the validations using the field function. We can do things such as adding max length, min length, and so on. But I'm going to skip that for now. So what we've done is to basically go ahead and add that to our file. So let's go to our service. So within our service, we are going to define another method that is going to be called create a book. So in this case, we're going to define this and call it create book. So this will take in self, and what we need is the book creation data. So we are going to provide that as an argument. So we shall say book data, and this book data is supposed to be a dictionary of some sort. So we're going to say that we shall need the book data. And once we've got the book data, we're going to go ahead and unpack that, or basically create a new book instance or a new book object. Once we've created that, we shall add it to our session and then use our session to commit it to our database, therefore creating the book. Now, if you're to notice, this is so similar to how we do it with SQLAlchemy. So what we shall do is to come right here and create a new book. And this new book is going to be, sorry for the AI mistake, and this book is going to be an instance of the book data. Okay, so what I was saying is, because this book data is going to be received as type of book create model, it doesn't make sense for us to unpack it this way. So what we're going to do is to come and unpack it as book data dot. So in this case, we expect this book data to come in type of the book create model that we have right here. So we can also go ahead and do that. So to make this more interesting, we can say from dot schemas, we are going to import our book create model. And once we've been able to do that, then we shall say that this book data is going to be of type book create model. And once we've been able to do that, now we can simply say that we can say this is going to be passed in as a mapping or a dictionary, but we shall just basically go ahead and model dump it, or dump it as a dictionary. So in this case, we shall say model dump, and that will be enough to return it. So that is just enough for us to basically go ahead and return the dictionary, or unpack this dictionary as attributes of this newly created book object. Once we've done that, let's use our session to go ahead and save this to our database. So what we shall say is session. So in this case, we shall say await self.session.add new book, and then we shall go ahead and commit this to our database using session.commit, and that will be just enough for us to create a new book. So once that is done, let's go ahead and try to make use of this within our routes. So when you go to our routes right here, we shall go where we create a book. So in here, the first thing we're going to do is to first of all create a new book. So in here we shall say new book. Actually, what we can do is to return a new book after creating it. So we can simply say return new book after creating the new book. So once we've been able to do that, we can just come here and say that our new book is going to be a result of using our book service to create the new book. So in this case, shall say it's going to be a book service instance. It's going to take in our session, and we shall call the create book function. So this will take in the book create data that we've created right here. So we shall just pass in the book create data. Once we've been able to do that, then we are simply going to return the newly created book. Now, if you can notice, it's going to return a status code of HTTP 201 created. So let's try to create a new book. Now, if we go back to our models, all we need is title, author, ISBN, and description. I'm going to copy this, and then we go back right here. So I'll try to create a new request. So I'll go to our collection, I'll create a new request, and this new request, I'm actually going to delete this, sorry for this. So I'm going to create a new request, and this new request is one for creating a new book. So I'll say create book, and inside here what I'm going to do is to first of all make this a post request, and this post request is the one that's going to be to the /books endpoint. So when you try to send, we shall see that our Pydantic is telling us that we are missing a body, so it's doing some sort of validation. So let's go ahead and provide a body. So we shall come right here in Postman and say we are providing a body, but that body is going to be in form of raw JSON. So I'll provide a dictionary or JSON right here, and then I'll go ahead and add these values. So we shall start with our title. Our title is going to be a simple title, so I'll make this a string, or basically I put it in double quotes. Then let's start by providing this. So I'll say this is going to be our sample title. And I'll add the missing comma right here. So if we try to send this book, we're now seeing that our body and description are missing. I don't know why. Let's go back. So we are missing that description, as I named it description, that begins with a capital D. So this is interesting because we're now seeing that our validations are working. So I'll go ahead and change this to description. And when I send, we're going to get an error. So I'm going to go ahead and see why this is happening. So our core return object is not iterable. So remember, we called our book service method of create book without having to await it. And I think that's why we are getting that error. So let's go ahead and await. So when you await and try to create this again, we're now going to see that we still have an error. So let's debug it. When we go to our code or our console right here, we see that this is an invalid input. So invalid input for query argument 6, which is the one for the date time. So we now see that we provided the date times wrongly. We have provided a built-in method for now of object. So we provided that date time objects wrongly. So let's go ahead and fix that. When you get to our models, the mistake we did is to define this by providing field and then default of that. What we are supposed to do is to go right in here. So what you needed to do is to basically say SA column, And in this case, this was going to be column, and we needed to basically provide this as date time. So we needed to go ahead and provide this as date time. So let's go ahead and do that. So what you can do is to define this as timestamps, and the way you can do that is by basically saying pg.timestamp, since PostgreSQL has those timestamps. So this is a timestamp without a time zone. And then you can specify that you want to have a default of date time now. So this is what we actually needed to do. We're going to do the same thing for our field of updated. So I'm just going to simply copy what we have here, or let me actually first format it, and then I will go ahead and do the same exact thing that we have right there. So what I'm going to do is to go ahead and run our server again. So our application startup is complete. We shall try once again. And now we see that our book has been created successfully. So now we've successfully created a book. So now let's speed code the remaining endpoints. So what I'm going to do is to go back to our service, and I'm going to basically create the rest of the endpoints. So the rest of the functionality. So I'm going to begin with one for getting a single book. So I'll say async get book. So this is going to be the book UID, which we shall receive as a string. And then inside here, we're going to create a statement. And this statement is going to be the one for selecting a book where the book UID is equal to the book UID we've supplied. When you execute the statement, now we shall basically get our result, and we shall get the first occurrence that will be returned from our result. Let's do the same thing from our updating a book. So our updating a book is going to be sort of like similar to what we had when creating a book. We shall need the book ID, but we shall also need the book create data. So we shall need to provide that. So I'm going to come right here and say book create data, or this is actually going to be the book update data, and this is going to be a dictionary. Or we can actually make this interesting by using the same way we did it for the book creation. So we can say this is going to be of type book model, because we expect the same fields to be used when updating the model. Now the first thing is going to be for us to get that specific model. So for us to be able to do that, what we can do is to first of all select the book with that specific book ID, just like you see right here. And once we have been able to do that, then let's go ahead and get the result. So for us to get the book, we have to go ahead and say book is going to be equal to the statement when we execute it with our session. So this is going to be session.exec, then we provide a statement, but this is going to be the first occurrence, so shall call .first. And once we've been able to do that, now we're going to update this book by accessing each of the keys and the values within the book attributes. So what we shall do is to basically go ahead and unpack this book update data, and then set the attributes of the book to the book update data that we've sent via the update request. So what we're going to do is to say for key and value in the items that are going to exist within the book update. So actually we're going to get to, sorry for that inconvenience. So what I'm going to do is to update this for key value in the book update data. So shall say book update data. So this is going to be book update data, which I wrongly spelled by calling it book update date, but it's going to be book update data. So I want to access every item that we have within our book data, update data. And then what we want to do is to go ahead and set each attribute that we have on our book that we want to update to the newly provided attributes. So in this case, we are going to say book, or we're going to use the set attribute. So we shall say set attribute and provide the book, and then we shall provide the value. So in this case, what this will do is to update each of the fields or attributes that will exist on the book with the attributes from the dictionary, or with the keys and values from the database. So in this case, we are simply going to basically, so this is not a dictionary by default that we've done here. This is going to be of type of a Pydantic model type. So if we want to make this a dictionary, then all we have to do is to add dot model dump, and I think that's something that I had forgotten. We are going to learn into that era again. So once we've been able to do that, now let's go ahead and add this to our session as well as to commit it. So what we shall do is to actually just say await session dot commit, and that will be just enough for us to go ahead and save it. But we are going to be using the session that we defined on our class, which is our self.session. So I'm just simply going to correct that. So once we've been able to do that, now let's go ahead and make use of it. So I'm going to go back to our routes right here, and I'm going to begin by first of all implementing that for reading a book. Or let me just finish up with the delete one. So the delete one will be much more simple because all it needs us to do is to query that specific book, and then just go ahead and use our session to delete it. So I'll say async delete, and in this case we shall delete a book. So this will take in self as well as our book UID. So it shall provide our book UID. And once you have our book UID, now I always forget the def after async. So what I'm going to do is to go ahead and provide or query for our book, which we did right here. And we shall query for our book. And after querying for our book, so our book is going to be queried from a statement. So we shall say statement is going to be equal to select book, where the book ID is the book ID. And after doing that, we shall get the book using our session, and after doing that we shall use our session to delete the book. So in this case we shall say await session or await self.session dot delete, and in this case we shall pass our book. And once we've done that, then we're going to simply go ahead and commit our session. So for now, we've basically done our CRUD and we've successfully been able to pull it off. So if you go right within our Postman, let's try to update our book. So one thing that I had actually forgot is that we need to go ahead and pass this onto our routes. So let's go to our routes, and we're going to begin with the one for getting all books. So we are going to get a book or a single book. So we shall say book is going to be equal to await. In this case, we shall say book service dot get book, and we shall return our book. So in this case, we are going to pass in our book ID, and that will return our book. So let's go ahead and test that, hoping that our server is running. When we go back to our Postman right here, I'll go to our collection, and in this collection, we're going to go to the specific part, so where we create our request, and we're going to name this request one for getting a single book. So I'll say get single book, and once I've been able to do that, then all we're going to do is to access a book with a certain UID. So when we get all books, this time we expect to get all the books that exist within our collection. So let me make this a little bit smaller, and we have one book right now. So if I try to copy this and try to get that single book, we shall now return that simple book, just like we see right here, which is interesting. So let's go ahead and also update. So I'm going to go ahead to the update section. So this is going to be the same thing. What you shall say is updated book. So this is going to be the updated book, and this updated book is going to be await, and in this case we shall await our book service dot update book, and all we have to do is to provide the book. So in this case what we need is going to be the book ID or the book UID, so we shall provide it. And also we are going to need Actually, that's all we need, because in the service we define this as update book, and all we need is the book ID and the book update data. So I'll just come and simply provide that. Now we call this our book updated data, and we haven't yet actually provided it, so I'm going to at least fix the way these are because they are not readable. So this function is going to take in the book ID, the session, as well as the book update data. So let me actually just add that right here. So this is going to be the update data. So this is going to be of type it's going to be of type book create model, just like we did for the create endpoint. And I'll add a comma to fix this. And once we've been able to do that, let me format it so that it actually looks a little bit organized. So this is going to take in the book update data. So the update book method is also going to take in the same. So if I provide that, I'll say this is going to be our book update data, so which you called update data. So I'll just come and provide it right here. So we don't need a session because we already have that session if we create the instance. So I actually called it weirdly by calling it as a class method, but it's simply an object of book service. All right, so we have now been able to update our book. So let's go ahead and just simply return the updated book. So if we say return updated book, that will be enough for us to update our book. So let's save and try to test this. If we head over to our API side or our API endpoint, we shall now go ahead to our Postman. If we go and try to create, or we shall create a new request for updating a book. So let's just call this update book. And in this case, we are going to make it a put request. Now, this is going to be very similar to what we have here, but we're also going to have the body that is similar to where we created our book. So I'll first of all go ahead and provide that body in here by going to the body section and then providing the body in the format of raw JSON. So if we provide this, then we're going to make sure we update. So I'm going to pull this to the side and increase the size so that you guys can see. If I come and say this is going to be our updated title, and then I come and say that the author of this is going to be, let's say, Sally Jonathan, and we are going to also make changes to the ISBN by, let's say, providing whatever that is. So I'm also going to make sure that we change this to updated book description. So let's try our luck and see if we send this request, we have an error, and let's see where that is. So it seemed like we never awaited something, and that is something in the service. So we have self.session.exec, which is a coroutine, but we didn't await it. So I'm going to add await, and when we save, our server will restart. So if we go ahead and try to make this request again, still have an error, and still exec was not. So that's where we get. So this is actually a coroutine. We are being told that session.exec statement.fast is a coroutine. Now these are the dangers of using AI when coding. So let's take a look at our code. When you look at our code, we have session.exec statement, and then this is going to be a coroutine object. So let's see where we made the mistake. We need to get, okay, so what I'll do is to just simply create a result. I'll create this as result, and then after creating this as the result, I'm now going to go ahead and say that our book is going to be equal to result dot fast. So it's going to be result dot fast. I have no idea as to why it's behaving this way, so I have to find out. So I'm going to get rid of this, and then when you remove that, then we say that it's going to return .fast. So if I save and try again, we are simply going to return null. I don't know why that is happening, but let's go ahead and see. And it's returning none because we didn't return the updated book object. So let's try to do that. So if we return the book, in this case, it's going to return our updated book. So if we try to send, it's going to basically return our book that we have updated. Okay, so let's deal with the last part of our video. So we've created our books, we've been able to retrieve a single book, we've looked at how we update a book. Now let's go ahead and test the delete book. So I'm going to head over to the service to check if I have any errors. So I'll read through this code. So we have book session.exec this, but what I'm going to do is the same thing we've done for the update. So I'll say result is going to be equal to the execution.fast, and then the book itself is going to be got from result.fast. So I'll try to do that. So once we've been able to get this, then all we're going to do is to test this specific API endpoint for deleting. So I'm going to go ahead and save, and when you head over to our routes, in this case but let's first check if we've been able to successfully update. If we try to get a single book, just like we did right here, it's going to be updated, so just like we see right here. And if we try to get all books, we have only one book, so let's try to create more books. So if we go right here, we can create maybe a book with a sample title, sample description, just like we had. If we get all books, now we have 2 books within our simple REST API. But let's try to delete a book. So we need to go to our routes, and then we go to our endpoint right here. So since we are not returning anything, we are just simply going to say await book service.delete book with the book ID, and then we shall not return anything, therefore return no content. So I'm going to save, and what I'll do is to go to our collection. I'll create a new request. So this is going to be a new request, and this request is going to be delete book. So this delete book request is going to be sent at this specific URL. So if we send, we are going to return, I don't know why this is actually a get request, but we want to carry out a delete request. So if we go and say delete, if we send this, now see we have an error. So something we never awaited somewhere. So we go back to our service right here, we're going to notice that we still ran this without awaiting. So if I await, our server is going to restart, and if we try to do it once again, we'll see 204 no content. And if we try to get all our books, let me actually make this a little bit smaller. So when you try to get all our books, what was a list of 2 books will be returned as a list of 1 book. So let's test this on our Swagger UI. So if you go to our docs that we put right here in the browser, and we try to browse through what we've done so far, we are going to notice that if we try to get all books or read all books, we can be able to get a list of our 1 book. So if we head over to our post where we create a book, we do not have anything, we do not have a way to create these books, so we haven't yet defined that. But that's something that we can do with our settings config dict. So for us to be able to do that, we can simply go to where we created our schemas, and inside there is where we can go ahead and do that. So we can say model, and this is going to be our model config. So the model config is being brought because this is our Pydantic model. So if we say model config, the model config will be a dictionary. So in this case, we shall create this dictionary, and in here we are simply going to provide the following attributes. So what we want is the schema. We want to go ahead and provide the JSON schema extra, which is basically a description of the fields that we want to submit whenever we are creating a book. So if we provide this is going to be a dictionary, and it will have an example with the specific data, just like you see right here. So I'm going to provide this as John Doe, and then we shall have the ISBN and the description. So if I save, when you go back to our UI and I refresh, shall now notice that when you try to create a book, we're going to have an example of how to create one, which is wonderful. So if we try to create a book right here, and let's say we just add this book just like we see it right here, shall execute, and this will basically create a book. So our book has been added to our API. So we now see that this is a complete list of books, and yeah, we can build so much to add to this specific book service. If you've made it this far, please click the like button and don't forget to subscribe if you're new. This video has been one to create a simple web service using PostgreSQL, FastAPI, and SQLModel. I hope you've enjoyed this video, and if you like more videos, please leave a comment down in the comment section telling me which video you'd like to watch. Also, I have a goal of reaching 10,000 subscribers this year, so if you can help me achieve that, that will be very helpful. Thank you so much for watching, and I'll see you in